Awesome. Well, without further ado, I'll hand it over to Everett.
Thanks a lot, Karthik. So here we go. Here might even just get that right in front of me. So thanks so much for coming out tonight. Join us at Container Days, please. So what I'm talking about tonight is joining 100 nodes to a Docker Swarm. And this actually was born out of an effort from a Docker captain named Chanwit just before Docker 112 did their final release. He wanted to kind of prove out what it looked like when you had like a lot of nodes joining a swarm with some of the release candidates that Docker was releasing. So he started this effort, which he kind of branded Docker Swarm 2000 on Twitter, and just started looking for people to contribute nodes to the effort. And I got notified of it from a friend at Docker, and like, oh hey, I think Rackspace might have some nodes, and like, yeah, I got nodes. I can certainly help out. And it all just kind of came together. He put together Chanwit, that is this repo for kind of coordinating the effort. And kind of describing what it is he was doing, what his goals were. Pretty modest. Like, this was the first effort of this. Honestly, just being able to organize all these people contributing all of these nodes in and of itself was like, I thought that in particular was a goal in itself. And then actually seeing how Docker 112 performed, to me, that was like icing on the cake. So he had this setup with 3 manager nodes running in some cloud. I don't recall which at the moment. He's probably got it in the documentation somewhere. And he was basically just going to open them up, give us the security token for joining the swarm, and say, have at it. Tell me how many nodes you're going to join, and we'll give you the token, and we'll just get you to join them. So at that point, here was kind of the minimum requirements for the nodes that you had to bring to the swarm. And once you had that, you were good to go. And maybe I'll touch on the analysis that he did, kind of after the fact. He was running Grafana, and I believe InfluxDB behind it, kind of capturing some metrics from his swarm and displaying them in Grafana. Okay, so what I did was really, honestly, pretty simple. I just created 100 nodes, I installed Docker, and I joined them to a swarm. And I used a handful of tools to do that. So we were doing the release candidate 4 of Docker 112 at the time. This was about, what's the date on this? August 5. So, a week or two before this actually happened. And, I was kind of toying, how am I actually going to create these 100 nodes? There's, of course, a variety of different ways. What I ultimately did was just write a couple bash scripts. One, to actually spin up the virtual machines on our Rackspace public cloud. I've got like a public cloud account that has a lot of capacity, so I'm able to do these sorts of things, relatively conveniently. And then, how do you actually get Docker, the 112 release candidate 4, onto those VMs? In this case, I chose to actually provide the VMs with a Cloud init script. And if you're not familiar with Cloud init, it's basically like kind of a post-boot hook for a lot of operating systems, a lot of Linux operating systems that support it. In my case, I was using Ubuntu, and it supports Cloud init. So if you provide it with this script, when you boot it up, then it'll just, once it gets to that point in its boot cycle, it'll run that script, and it'll go ahead and install Docker for you. And that's all that. So rather than showing you this gist here, I'll flip over to, I'll go ahead and I'll run this right now. and we'll see if I can actually get something created in time. So I'm going to create a couple of nodes. I've already got a couple running because they do take a few minutes to get going. So run the script and provide it with what's actually a function name. So all this is doing is, so this is the bash script that I just ran there. It's got a handful of functions in it. And at the end of it, it calls main with whatever you passed into the script. And all main does is echo out and then run this loop function over the function that you actually want to run. So I'm running the create function in this loop. Oh, you bet. Yeah, thank you. Yeah, sorry about that. Yes. Great, thank you. Yeah, so looping over that create function, and I'm just using this utility that that we developed here, actually on my team, the developer experience team, that is a CLI for spinning up instances for basically working with resources on the Rackspace public cloud. So I go ahead and I create however many instances I've gotten here, and I'm creating a sequence of them because I want to number them so I can come back to them and iterate over them as I like to. And there's a lot of other technologies I could have chose to do this sort of thing, like Ansible or Terraform or whatever. But this is kind of a one-off thing, and I could script it pretty quick, so that's what I went with. So if I look at my cloud control panel, they're up and running right now. And what that means is, so even though they're actually the virtual machines themselves are active, that means that the cloud init script that I provided to them is actually running on them right now, reaching out to the Docker repo and pulling down Docker. And that script looks like this. So this is what those virtual machines are doing right now. Executing this little bash script here that just, of course, I want to disable password authentication. That's just like good hygiene. I started these things up with a key pair that I already have. So they're locked down that way. Install fail to ban, again, just good security hygiene. And then this is stuff, pulled straight out of the Docker installation documentation. Just go ahead and install their certs for, for this repo. And then this is really kind of the key piece here, is providing the experimental part of this repo so that you can get the release candidates from Docker. And then once you've got that and you've updated your sources, you install some extra stuff. I think that's for AUFS, if you want to use AUFS. And then I specify RC4 because that's what we were testing specifically, rather than just grabbing whatever was there, because between when I wrote the script and when I actually ran it, who knows what, they could have released another release candidate. But we had targeted RC4. And then go ahead and start it. So I'm going to switch back to my script, and I've got 4 nodes running now. And I could have provided this stuff as parameters to the create call, right? But just being a little bit lazy and just editing the file instead and just keeping it pretty simple so that all I have to do is put one thing on the command line here when I actually want to do stuff. So if I want to take a look at what versions I actually have deployed across the nodes that I created, I've got this version function that goes out and just runs Docker version and reports back on the version it's running. And then if I want to kind of test out the installation and actually download and execute an image, run an image, I should say, I've got this hello function. And the other purpose of this was that I knew that some of the tasks that Chanuit wanted to run on that massive swarm we're using the latest Alpine image. Well, this hello function just runs the hello world Docker image, which runs on the Alpine latest image. So it was kind of just a way to warm up my nodes for being included in his cluster. So kind of covered, that was the hello function. This one here. So again, I'm just SSHing into the server and running a command. Really, really very basic stuff. And then that's all describing all that. So then it came down to, actually joining that swarm, joining my 100 nodes to that swarm. And we all got together on Gitter, I believe it was. He may mention it in his blog post, but we were all coordinating through Gitter. That's the chat? Yeah, GitHub chat, basically. So we were all coordinating through Gitter, and he let us know what the token was to actually join the swarm. So that's the one command where I provided a couple extra arguments, made those available to the script so that I could just do Docker Swarm 100 join. Here's the secret, and then the IP of the current manager of the swarm. And I don't actually have any managers running at the moment, so I'm not able to join anything, but you know what? Let's just try it anyway. Sorry if that's too small. And this is going to fail miserably, of course. So, and then you'd provide some IP address, and it's just going to wind up timing out as it actually reaches out to my nodes and attempts to join a non-existent manager. And what that command does is this. It just runs Docker Swarm join, provides that token, that secret token, and the swarm manager IP.
That's running on all 100 nodes?
Yeah, that's right. So that was going to iterate over all of my nodes and run that join command on each one. One of the other reasons I did it as a script was because, I don't know, I could have done it all parallel with some other technology, or even with other scripting stuff, parallel SSH or xargs or, whatever, or even just forking. But I was like, joining like 2,000 plus nodes to this swarm, I figure if I just go kind of one at a time in a nice plotting kind of sequence that, I don't know, maybe it'll go a little smoother. And I actually had no problem joining any of my nodes to the swarm. They all just joined on the very first try. There were a few users who were reporting on Gitter, like as we were chatting through that, they were having trouble joining. But all in all, I think almost everyone was able to join all of their nodes to the swarm. And he does a great analysis here in this blog post and kind of talks about some of the things he was doing, running very basic task, in an Alpine image throughout the whole swarm. And he was able to dial it up to actually kind of an amazing number of tasks here, almost 100,000. Didn't quite cross that 100,000 barrier, but got pretty darn close. And the managers responded remarkably well. This was pretty darn near the peak. Almost 2,400 nodes as part of this, all across the internet as part of this swarm.
How long did it take for all 2,000 to jump from start?
So the question was, how long did it take for all 2,000 plus nodes to join from start to end? We started at I think it was a Friday morning-ish. And we did actually kind of a bit of a dry run where we just joined like a handful of nodes to his manager at the time. And then he actually wanted to rearrange things. He wanted to like drop managers, change leaders, I should say, add managers, change the leader. He was kind of playing around with it. And so the dry run went fine. And then it was probably like all told, a good 3 or 4 hours of just like coordinating and back and forth and people coming into the conversation and actually being able to join their nodes. My 100, yeah. I didn't take any timing. It probably took about, honestly, like on the order of 100 seconds-ish, It was just how long it took to, and that actually includes the time I do a lookup for every single virtual machine. I look up its IP address, and then I'm able to SSH to it and run that command. So I'd probably say somewhere between, 100 and 200 seconds. So like pretty reasonable, really. What else is interesting? Yeah, and his the manager seemed to handle the load really quite well. And even when he was changing them around, like when you see these peaks here, it's when at periods of change, and he specifies them here when he's actually changing leaders or upgrading or what have you. I encourage you to go ahead and read through this. I'll share the link to my post in the comments of the meetup, along with the video, and you can go ahead and review this. So here's where it kind of reached the peak of the number of tasks he was actually running on the swarm. And it was just really kind of a interesting effort to be a part of. And it was like significantly lower effort than I was expecting it to be. When I first learned about it, I was like, oh man, that's going to be, no one's done anything like that with Swarm yet. It's going to be a bit of a, it could be problematic. It could be, who knows what you're going to run into, all the unknown unknowns. But it actually went really pretty smoothly. I thought, to me, that was the most impressive result. Like the 100,000 tasks and that the managers stayed up the whole time and he was able to change leaders and stuff. The technology worked great, but just how smoothly it all went. And the coordination, I thought that was, a great aspect of the whole effort as well. So that's pretty much everything I had to say about that. Did anyone have any other questions or? This one here? Oh, sure. This is just the different managers. Yeah, and it's their CPU usage. So here, and I'm kind of remembering this stuff as I'm talking. Right, manager 2 goes down at 1950. Yeah, so here's where manager 2 drops off. So you don't see the blue anymore. But the CPU load on the other managers was kind of negligible. And then here at 2010. Manager 1 goes down, and manager 2 is already online at that point. So it picks up the slack, and so does manager 0. It picks up the slack, right? And then looks like, manager 0 goes down at 2035. I guess that's around here. Yeah, right. And then these managers just continue chugging along, and actually it kind of evens out towards the end there as we were removing nodes and the whole effort was kind of winding down. Well, could you do the same on the next graphic? Sure. Okay, yeah, so this was the tasks that he was, and it's of course not zooming the image, so it's kind of hard to see the state of the tasks. So this is, over the course of adding the nodes and actually running tasks on them. So he really started running tasks on the swarm, at roughly 22:55 and ended about an hour later. And he was able to dial up to 100,000 accepted tasks, and looks like got to about, half of those were complete by the time the testing ended. And then there's these other various states that they were in as well. Some accepted. What else do we have here? Some started. These ones were complete. Possibly, I'm having trouble seeing exactly what that color is too. Possibly failed. Might be shut down. Yep. Just one sec.
I think you had a question.
Uh-oh, microphone.
You can do it.
Okay, twist my arm. What were the tasks being run?
Trying to remember. Yeah, I'm not exactly sure what the tasks were. I can't recall off the top of my head. I'd probably have to dig through the repo to see. I'm not sure if he actually included the tasks he was running on the swarm here somewhere, or in one of the previous branches. He did make all of the data files, all the data and metrics from the testing available in this repo as well, and you can find them here on dream.io. Yeah, sorry, I can't answer that off the top of my head.
Hey, Everett, in the previous graph where we see that huge spike, is that when nodes were being added to the master? Is that why? Not this one, the previous one. Yeah, if you see node 0 here, and even node 2, that huge spike at 20.
Yeah, 2010.
Yeah.
I think that's more due to one of the managers dropping out than anything. Let's correlate that to 2010. Let's see what the tasks were like at that point. Yeah, so that's before he even started adding tasks to the cluster. So this is while we were still kind of growing the cluster by adding nodes. And this is the part where he was kind of testing, dropping out managers, and upgrading them, and then adding them back into the leadership cluster, into the quorum.
So I guess that's all the effort for a different manager to take on the load of, okay.
And I imagine, I'm kind of speculating at this point, but the Raft consensus algorithm that's running in the managers, I imagine it has to sync, and once a new leader is elected, there's probably a whole lot of stuff going on there that it has to do in order to make sure that it's actually in a good state.
Yeah, I wondered if there was any meaningful metrics or data that had been derived from it being such a distributed amount of hosts, right? Performance-wise, problem-wise, right? Was there anything that came out about it being that diverse a set of?
Yeah, so there were a lot of people with that same question, like right at the end of the testing on Gitter. Some people were like really kind of pushing on we really want some hardcore performance metrics, and The rest of us were like just kind of happy it happened, and the whole thing went smoothly. What I'm hoping for is I hope that sort of thing kind of becomes I'm hoping this effort continues. Like he's renamed it. Chanwit has renamed it Swarmzilla. From Swarm 2K, he wants it to be Swarmzilla, and hopefully it'll become kind of a routine thing. And when we're able to, now that we've got one run under our belts, we can start looking at maybe some of those kind of nittier and grittier performance metrics of running a really distributed cluster like this, what that actually means to Swarm.
Gotcha.
Okay, thanks so much. So now let's turn it over to Karthik.
Sweet. All right. So you'll already know me. My name is Karthik. I recently found out that I had a cool title at Oracle. I thought I was like a senior developer, but it's like principal member of technical staff. It's a whole mouthful. But that's what happens when you get acquired and then they give you like a cool title, is what I realized. I'm a part of the Oracle public cloud team. Yes, Oracle does have a cloud. It's not really well known, but they're trying to like push a lot of their applications and things like that into more of like a PaaS service slash IaaS service. Before Oracle, I used to work at a company in town called Stack Engine, and that got acquired into Oracle. And our product was it was more of like a front-end thing for Docker that you can use Stack Engine instead of using Docker on different machines and whatnot. So it helps you with the management slash orchestration layer for Docker. And that's been rebranded to an Oracle Container Cloud Service, which we'll announce super soon. All right, so as Oracle, like it's a huge company, so I kind of wanted to talk about like the different things that we do as a company with Docker. And over time, like it's been about 8 months since we've joined Oracle, so we've kind of gotten to see like what different folks and different teams are kind of using Docker for inside of Oracle. So this is just a quick thing of like the different things that I've seen. So from a customer perspective, probably like the biggest one is Oracle Linux. So Oracle Linux, you can use that as a base Docker image. Instead of Alpine or Ubuntu or whatever, if you already have, like the use case for it is, if you're already using Oracle Linux for your products and things like that, and you want to use, Docker, there's a version of Oracle Linux that you can use as a base. That's already out there. And I'm guessing like most folks, kind of already know about this, right? So quick show of hands. How many of y'all knew Oracle Linux was already there? A few, cool. Other stuff that customers kind of ask us a lot about is we have like a GitHub page for Oracle blessed Docker images. They're not really images; they're more about how you can build the Docker image for it. And so one thing that a lot of customers that I found out have asked about is WebLogic. So one of the most common use cases is like, hey, I have this WebLogic server. It works really great, but I want to run this in my dev and test environments as a container. How do I do that? So there's a lot of examples that we've kind of provided out. Things like WebLogic is the big one, but other ones out there in that GitHub repo are Coherence, Oracle Database, JDK, HTTP server, Tuxedo, which is another kind of like HTTP server for C++ applications and whatnot. And from an open source perspective, there's Glassfish, MySQL, NoSQL, OpenJDK, which is actually, I think that's more popular than using the Oracle JDK for obvious reasons, and Oracle Linux, of course. Yeah. So the big thing, that I think most folks ask for right now is with respect to WebLogic. So how many folks actually in the audience use WebLogic today? Quick show of hands. All right. Well, actually, that's kind of good because it's a little hairy. But recently, like the big thing that we announced was WebLogic 12.2.1 was certified to run with Docker 1.9. And this was published in April, which is pretty recent. But so they actually have folks in the Oracle Linux / Oracle WebLogic teams working to make sure that like all the different products and stuff that we have, like specifically, work with Docker. So the last version that they blessed stuff with was Docker 1.9, but it doesn't mean that it doesn't work with Docker 1.12. That's just the version that they've certified to run with. And then with that, you can kind of create clustered or non-clustered versions of Oracle WebLogic Server with different domain configurations. Single multi-host, whatever you want to do, like that'll still continue to work. And I put some blog links out over there. The interesting thing about this is when you look at the GitHub page, you don't actually have links to any of the binaries. So you actually have to go, pull the binary for WebLogic or whatever, accept the terms of service, and then install the Docker file. So it's not really that exciting from the Oracle perspective, but you'll start noticing that kind of pattern a lot with things where you need license files and stuff like that. They'll actually ask you to go pull whatever download it is, accept terms of service, get that, use your license file, and like build it into a container. So that's kind of more of I think a lot of companies that people are asking for how do you use product X inside of Docker. I think that'll be a little thing that'll become more common, or more of a common workflow. So internally, in the company, we didn't really know like whether people knew about Docker at all when we joined. But the nice thing is like we realized that was actually really popular, and a lot of teams. So the way Oracle is structured is like any big company, there are a lot of product teams. So like every team kind of does its own thing, and then they build products from that. But there's a lot of like integration between different teams as well. So a lot of teams kind of want to use Docker because Docker's the new hotness, and it makes your life a lot easier in a lot of different ways. They're kind of like experimenting with how to use Docker. Probably the most common use cases that we've seen is more for like in terms of CI. CI, you're building your environments, or for testing. That's where people end up using Docker a lot. It was kind of nice that we had a private registry. So we use Oracle behind the scenes in OPC. We use JFrog's Artifactory for publishing your Java docs, or not Java docs, but like Java jar files and whatnot. But you can also use that for storing your Docker images. So we actually use that. The caveat of that is it's a V1 repository. So I think JFrog has a V2 now, but the team that manages Oracle's JFrog Artifactory thing still has it on V1. So the annoying thing with it is anytime we want to use something internal, you have to like downgrade Docker on your local box, pull that, upgrade Docker, and then continue doing your stuff with 112 or 110. 110.3. So I think 110.3 is like, or 110.3 kind of works with V1, but it's still a little bit more painful. But that's kind of what we have. So until they actually upgrade it, that's what we have right now. That's just a quick screenshot of what it looks like. And this is like a sample Docker image that I'd created, that I took a screenshot of. So I actually want to talk about like one specific use case that I've seen. And a lot of times, so in Oracle Public Cloud, the way we kind of do product development from a container service is we we kind of give our artifacts to the test team to take and to publish to Oracle's cloud as a PaaS platform, right? And so one of the aspects of that is they want to kind of like test it and make sure that, hey, it's doing everything that's supposed to do and the workflows all work okay. But you don't really want to do that in a manual sort of way. So you want to, automate that somehow. So we kind of wrote, they were like, there's this test team, they need all your tests. They'll run that on a periodic basis. And we're like, great, that's easy to do. We can use Selenium, we can use a protractor, and kind of like jigger all this stuff together. And then, so I was kind of responsible for doing a lot of that work. And so when I started doing that, I started reading their documentation, and it was really confusing because they were like, well, you need the system test file here, and all your tests go in there, and then that has to have another directory next to it, and you have to put all the stuff over there, blah, blah, blah. And I was like, this doesn't really make a lot of sense. And it was literally like 7 pages of documentation. And I was like, okay, well, I guess that's how they want it. And so then I zipped it up and I did all that stuff, gave it to them. And by them, I mean, they had like a platform, like a TPaaS test automation platform that you uploaded everything to. And that would take it and run your scripts. Except that never worked. That was the first version of it, that they were trying to do everything from an automated perspective. So that didn't really work because like most of the time, it would pull down the wrong file, you didn't have your files synced up correctly, or you had an issue with, they wanted a zip file, but you tarred it, or something really asinine. So a lot of that team's time went with just kind of figuring out, oh, well, this is because of this specific bug for your use case. And that test team kind of supports all of Oracle Public Cloud, which are a bunch of product teams. So most of like their developer time was kind of spent on like really random sort of issues. So what they did was they ended up, and I talked about issues like test harness would always fail, or not always, but like 60, 70% of the time would end up failing. And then it was just something weird in there. And then eventually when you got to the resolution, you'd be like, hey, you should add this to your documentation. And so the problem with that was like the FAQ for it ended up becoming even longer. So it was just kind of a nightmare in a lot of ways. So one of the things that they ended up doing, which actually has worked out really well for everybody together, has what they did was they were like, well, we're going to build a base Docker image with specific paths and things to how we want all of your tests to kind of sit in. And then you can add your own tests and whatnot to that Docker image, and then build it, and you can store it in Artifactory. And then as a part of our workflow, we'll just, instead of pulling down the zip file from Artifactory, they would just pull down whatever image you have, and run that. So the benefits of doing it in this way was it was still a single thing that they were pulling down instead of zip file was a Docker image. But from a developer perspective, since it was like a different team kind of handing the Docker image to that team, you could kind of sit down, test all your stuff inside a Docker image, because that was the same thing that they were going to run with different parameters, and make sure that everything worked for you to begin with. And then you can also add like automation stuff in there. So one thing that I ended up doing was I just stick that stuff, and then anytime we push, make changes to the tests or whatever, that's when I build the actual Docker image and store it into our repo, and also run the tests associated with that. And then we have those tests kind of running on an every 15-minute kind of basis, like making sure that all the workflows and stuff work from a product perspective. And then they can kind of like from a test perspective, when you're doing like the watchdog, when they're running the watchdog tests from a production perspective, it still continues to run. So what's up?
So these were the test images, right, that were the test harnesses that were wrapped up in a Docker image. What about the application itself? How were those getting deployed to then be tested by this test harness? Did that involve Docker and all, or a completely different distribution mechanism? That's
a good question. So this was specifically for the testing aspect of things. So there are like other initiatives. So in this case, no, it wasn't like the app itself was Dockerized, but there are some instances where they've kind of they're kind of working on that, but not in this scenario. So this was specifically just for like the test stuff. And so they took their testing platform and basically Dockerized that platform so that they could kind of like scale it a lot better. And yeah, so it like helped from an understanding from a team perspective. So before you kind of wait and send off this email, and then you'd have like somebody frustrated on that team be like, you need to have these permissions as 755, blah, blah, blah. So it just helped like with gelling the process a little bit better.
Question on the periodically test out a Docker image. Mm-hmm. So why not? So why the every 15 minutes? Why not just like every single commit to a pull request test that out? Is that feasible or? We could do that too. So the reason this is periodic is so the test stuff lives its own repo. So like from a Jenkins job perspective, like we build it every time the test changes. But if this was sitting alongside with all of the code as well, then you can kind of like kick it off anytime there's any kind of code change, run this as well. But we started noticing like our code builds already take like 5-6 minutes to run. So then I was like, well, I don't want to add another like this only takes maybe like 2 or 3 minutes, but I didn't want to add that overhead to that and make it like a 10-minute build. But I think if this was sitting at these tests and this platform was sitting alongside all of the code, then yeah, certainly. Like anytime you push to that, this will also run as well. And so that's why I came up with the 15-minute run it every 15 minutes, even though that's kind of overkill. But it's it still helps you identify on average like when something started to break versus like a daily thing or whatever. Any other questions on this specific use case for it? Another thing that was done internally, and this happened around the same time we were acquired in December. They were like, Oracle does these internal hackathons, which I think are really cool. They'll basically pick one big area. So containerizing is one. They did one on big data. Every quarter they end up doing a hackathon. So like 2 quarters ago, they did one on big data. Last quarter, they ended up doing one on containerization. And so they kind of do it, at headquarters, remote, or like different, like larger Oracle branches. They kind of pick and they do that. And so some of the results from that, it's not really publicized except for just the one that actually won. But a lot of, so one of the product manager on our team, John Reeves, he was actually a judge on this. And so out of everybody kind of like participating in it, most of the folks are kind of like looking at this dev test use case of Docker. And the winning team actually was a product team, like a product testing team, similar to the TPAS team that I talked about. So they kind of do the same thing where it's like, they get a product and they're responsible for like testing different facets of it. So they ended up using like Docker volume containers to like reduce test burden and like build times, like reduce build times, not increase by a lot. So, and I guess that was the reason they won over some of the others was like the significance of that from a large enterprise perspective was a lot larger than, the other team, which also did something really cool where the cloud commerce team, so they have that whole product is based on microservices. But so when they're installing those microservices in a test or production perspective, they could just, have these scripts to install stuff. But they basically took all that stuff, Dockerized it. So when you're doing your CI push, that's when you build your Docker containers, and then you have Docker orchestration kind of manage that from a deployment perspective. So that kind of helped with their a lot from their build perspective and build time perspective. So that's kind of they kind of targeted more hey, I have microservices and I want to kind of Dockerize them. So they ended up reducing like their build time as well. And there were a lot of, I think there's like this, not really push, but there's this initiative inside of Oracle saying, hey,
how do you like Dockerize different things? So like there's the Exadata team took part, and they were like, I want to see if I can run this inside of a Docker container, much like some of the other ones that have been published on Docker or on GitHub. So they kind of ran their stuff, and then there's also like the Oracle Jet team, which is a framework that competes to Angular and some of the other like UI frameworks. They were able to like containerize that as well. So there's like this push inside the company to like say, how do we? Because I think there's a realization that people want to be using Docker, and Docker kind of makes your life a lot easier when you're trying to do like large kind of application building, whatnot. So there's this push to like push products into Docker as well, which is pretty neat. Yeah, I guess that's really all I had. Just wanted to like run through stuff real quick. What kind of questions do y'all have about that?
Just kind of random question. What's the size of the base image for Oracle Linux that you guys are using?
That's a good question. I know it's large. I don't know how large it is, but do a Docker pull in Oracle Linux, and I think it'll probably be. It's definitely not like Alpine. It's a lot bigger.
Okay.
I think Alan had a question up here.
Have you guys thought about publishing your licenses in actual Docker containers that then you could just source volume from, and then like your clients would just have registries that would have their license files in them, or set up like specific, like when I log in as Alan Scherger, I can get my license files via Docker containers?
Well, I can't speak to that from like an Oracle employee perspective, but because there's like liability with that.
Right.
I know there's a lot of conversation on that, and so currently the recommendation is like you can. The recommendation is when Oracle publishes something, something like globally or in GitHub or something like that, you go pull all that stuff down. If you're running stuff in your own, in your like inside of your environment, you can store those images inside of your public or inside of your private repo, just as long as you don't like share them with others. I think that's okay, but don't quote me on that. I'm guessing as things evolve, that will change. It's just a matter of time when that happens is what I'm guessing with it. Anything else? All right, I'm going to transition now to Alan, who's going to talk about Mesos stuff with Docker.
Yeah, I'm going to troll all of you. It's going to be great. Oh, okay, cool. Yeah, thanks. So the good news is my battery is like 30%, so this whole thing might get cut short. It'll be great. We'll find out. So for those of you who don't know, my name is Alan Scherger. I work at HomeAway. I deal with Mesos and Marathon quite a bit. We're using that to become our new deployment platform. What I'm going to show you tonight has absolutely nothing to do with what I do at HomeAway aside from using the same tech. But recently, Mesos did a new release, Mesos 1.0, and with it came this new containerizer, what they're calling a universal containerizer, which is pretty cool. And this is where the trolling comes in, because with the universal containerizer, you actually don't need the Docker daemon installed on your agents anymore. So I don't know, show of hands, how many people have seen Mesos or understand the architecture at all? Okay, so real quick, there's basically, you have a whole cluster of computers. You set aside roughly 3 or 5 of them to become known as masters, and then you turn the rest into agents, and the agents can just run distributed tasks that are sent to them via the elected master. And in order to get a job scheduled onto the master, you write this thing called a framework, and the framework uses the master to use the agents to actually get your things sent out and distributed. I can probably show you a quick, like, kind of how this works with Marathon here in a few minutes. Marathon is like one of the most popular frameworks to actually deploy work onto a Mesos cluster because they pivoted themselves towards being like the way to deploy Docker containers onto a Mesos cluster. And typically when you would set up these Mesos clusters, all of the agents would also have to have the Docker daemon running. And so now with 1.0, and as everybody moves towards these kind of open container standards, you actually don't need the daemon anymore because the Mesos agent itself will confine to those same standards and is able to take a Docker image and actually run it as a container on your box. So it's one less dependency that you need. And as far as like backwards compatibility and ensuring that like, hey, my Mesos cluster is going to work from Docker version to Docker version, well, it will because we're just going to conform to these standards. And that's pretty cool. So I just found out about this feature like probably a week ago, and I just got it running maybe an hour ago. So we'll do a live demo. I'll walk you through what I did, and hopefully it still works. So the first thing you're going to want to do when you set up a demo is set up a VPC. I've become somewhat of a Terraform fanboy. If you want to check out some new features in Terraform 7, they're in this repo. It's pretty sweet. Maps and lists are now like first-class citizens. And we could talk about that tool all day, but that's not for now. Can you see that at all? Probably not. How about that? Better? So I'm going to spin up a node. The first thing I'm going to do is like upgrade everything. So I'm on the latest, greatest kernel from Ubuntu. Then I'm going to actually set up Docker. So I run Docker on the masters as just an easy way to deploy helpful things like DNS mask, console. I actually run Zookeeper in Docker as well. You can run the masters in Docker. You can run the slaves too, but the slaves get a little chainsawy. So this is not necessary to use Docker, but this is how I use it. And it's pretty helpful because I can keep my kind of what makes up an instance really short. And then we use containers to actually build out like from this one instance type, I can build anything because my like Docker is my little malleable tool. So that's pretty cool. So we've added the Docker repo. We update our repos. We install extra packages so that we can get like AUFS. We install the Docker engine. I actually use a tool called Container Pilot in my exhibitor container. And it's really particular about network hosts. So I actually like the names of network interfaces. So I disable the systemd like automatic naming that isn't actually helpful for anyone unless you are working on systemd. I don't know if any of you have like had to deal with that, and maybe I'm just alone, but it drives me nuts. So at any rate, this hack will make it so that when I boot my machine up, I'll get etho back and eth1 back, and it won't be some random name based on the NIC name and all kinds of stuff. So I've rebooted. I've got a clean version of Docker running. Now I kick off my exhibitor container. Show of hands, who knows what exhibitor is? Right, so exhibitor is this sweet little Java sidecar that you run next to Zookeeper. Anybody know what Zookeeper is? So yeah, distributed key value store. So if you're not using exhibitor and you're running Zookeeper, you probably should go check out exhibitor because it does some cool things for you, like coordinate all of the IDs of what your Zookeeper nodes are going to be. It allows you to actually back up the config and the data in the key value store. It's pretty slick. You can check out that container. It'll run it. And it uses S3 to do all the node coordination. So you don't have to set up like yet another database to manage your database. That's kind of nice. Finally, so I've got Zookeeper running. We set up the repos for Mesos, and we actually install the latest version of Mesos, which is now like 1.01 and change. The package maintainers for Mesos require Zookeeper to be installed, and the package maintainers for Zookeeper have Zookeeper start on installation. That's real silly, so we turn that off because I already have it running. And we start our master, and that's it. You never had to do any more config for a single node master. You're off to the races and running. And like I can tell you, this is exactly all you need because I literally copy pasted it out of my history to make this presentation. There's no hidden magic. Let's see, you can probably see this. So on one of our slaves, or now they're renaming them agents. I need to get used to that. So on one of the agents, we need to do the same similar bootstrapping, but this time we're not going to install Docker because we don't need it anymore, or at least that's what the docs say. We'll figure out if they lied or not. So again, we're just going to install some packages that are probably completely unnecessary, fix our networking NICs so that they're named a sane way, and actually just install Mesos. Again, stop Zookeeper, because why? Why? So sad. Now we're going to actually do some configuration. So the Mesos agent needs to actually know where the Zookeeper cluster is. So if you're clever like me and doing this in production, I'm going to actually substitute this out for data that's from console. But today we're not going to do that because we're going to keep it simple. So it's just a hard-coded IP of that previous master that we had set up. And then finally, we set up some environment variables. So you need to set up the isolation variable to this file system and Docker runtime isolator. I wish I could tell you exactly what that means. I have not dug into the code, so such is life. We could dig into it if you're interested. You need to set up the containerizers. So prior to today, you would have set containerizers equals Docker, which meant that when you were to go to deploy an actual task onto the Mesos cluster, it would use the Mesos Docker containerizer. But again, for today's presentation, we're not using Docker, so we just need the Mesos containerizer, which triggers the usage of this universal containerizer. And then a new feature that's to enable all of this is actual image providers. So they're not going to just support Docker images. They're going to support any of the open standards. So I'm pretty sure you can put appc in there, and that's supported as well. And what other standards come out for container images. And then finally, again, there's not much config here. You just need to start the Mesos slave process. And then I like to watch the logs. So a little journal control action there to actually watch what's going on. Next up is Marathon. So in order to, and here I can, maybe the gods will be nice. So if you did all of that, you'd have this Mesos cluster and you wouldn't see any tasks running. And you'd come down and the big win would be you'd have, you'd see that you'd have resources available because that agent would come up and register with the master and say, hey, I have like 4 CPUs available, some RAM and some disk storage. Like, have at me what you want. And you can go to agents and see that they are listed here. So this is my healthy agent that we set up. And then you would need to actually go start a framework so you could deploy onto the Mesos cluster. So to start up Marathon, I actually built Marathon from source because these features are pretty bleeding new. I wanted to make sure that if we had any hope of this demo working today, that we were using master. So building Marathon is actually really simple thanks to Docker. So you literally clone the repo. I updated the Docker file to actually use the latest version of Mesos because Marathon is written in Java. They use the JNI bindings for today to actually talk to Mesos. In the future, it'll probably be all over the new RPC API that they've just released in the latest Mesos and are constantly iterating on. So that'll hopefully go away, but this ensures that those latest libraries from Mesos get installed. And then we just simply build Marathon using Docker. They have a Docker file in their project. You can look at that. It's lots of fun. And then on our master, we take that container that we just built and we run it. And the only config that you really need is to tell it where the master is, which is, hey, where the Zookeeper cluster is off of this Mesos namespace. And then you tell it, hey, Marathon uses Zookeeper to store some data. So Marathon is going to store data in the Marathon namespace of that same cluster. You could run them in separate clusters if you really wanted and you're paranoid. I don't, but don't let me stop you from being paranoid. You're probably in the right because Zookeeper. So finally, we get to the snippet of JSON that is going to claim that it will actually start a Nginx process via a Docker image called Nginx, and it will start it up using that Mesos containerizer, which means the Mesos containerizer is going to go out and pull the image, take a look at what's inside that image, and actually spin up a container by itself using the Linux kernel. No Docker daemon required, and that's pretty cool. because it works, and I wasn't sure if we were going to have internet, but we do have the internet, and life is great. And so, yeah, this is like the Marathon instance running right now, running Nginx. It was scheduled, and if we, you'll see that a port is getting allocated. Right now, they're still working on getting networking and advanced networks working with this containerizer. So by default, it will use the host machine, and it will auto map all of the ports that are exposed in the image to the actual host. So Nginx exposes port 80, therefore port 80 gets mapped and started and is exposed on the host. But if you were to rejig your images a little bit, you can take advantage of don't expose any ports, take advantage of an environment variable that I'll show you in a minute, and you could actually be using this like somewhat today for real without any more code commits from the Mesos project. But yeah, here's Nginx. It is like totally running. And if you still don't believe me, we can get onto the slave. Maybe. Yeah, cool. So if we do this for like Docker, yeah, nothing. But if we do this for Nginx, you'll see that the Mesos executor process was forked from the Mesos slave. And the executor is actually siloed and isolated. And Nginx is actually started and running from that Docker container that was published to the public registry. So it's really there. If you do, you'll see like it's listening on port 80, and this is that ephemeral port that got mapped for free. And I'm a liar, so just ignore me. So one of the cool things, though, that's really weird. Huh, I should check that out. So they are placing these environment variables into the container, or they're looking to do that soon. So today, if you were to use the Docker containerizer, you'd get all these environment variables here. I don't know if you can read those. Maybe you can read them better. So these environment variables that get posted into this container allow you to do the bridge networking between the container and actually getting out to the outside world, outside the host. So what does that mean really simply? You're going to have like 50 containers running on this box. They're all going to maybe be the same style of app because everybody forked from the same base app. They all listen on port 8080, but I want them all running on the same slave. Well, I need to remap those 8080 ports to individualized ephemeral ports. Marathon makes it super easy for you to do that, and using environment variables, it makes it super easy to pipe in, hey, like, I know you wanted port 8080, but on the outside, you're really showing face at 31300. So you can map those environment variables into your app, and when you can either do it before you start your app, and you could, like, if it's Java, set up some system properties to wire that in, or just deal with it because it's just NAT. So it'll come into you, no big deal. It gets a little weird with RMI, but that's a whole other topic. Yeah, probably. Yeah, so the question was, could I type sudo in front of that netstat and actually figure out what process started on this port? And the answer is Mesos executor, and I'm ignorant and could not tell you why that is Mesos executor, other than possibly this container got restarted on this same slave and there's a bug. So in theory, that might actually, it should have been 31967, but because I'm on the same slave and the task got restarted, it could be the old port that was originally started. Bugs. It's brand new. I can tell you the Docker containerizer works great, as well as Docker works, because it's they just wrote a wrapper around the daemon for calling it. So, yep.
You lose Docker inspect features so you can monitor these Mesos created non-Docker engines.
Yep. So the question was, do you lose Docker inspect or any of the features of Docker by running containers this way? And the answer is absolutely yes. because there is no more daemon. So you would need to write tools to talk to Mesos in order to find out how these containers were running and or actually talk to the kernel in the operating system, because it is, after all, just the kernel that's actually doing all the heavy lifting, not these user land tools. Yep. So the question was, what is the benefit to this approach? And I would tell you the benefit is that when you wake up tomorrow morning and someone's threatening to fork Docker, I don't care because I wasn't using Docker. And if I have another development group that comes to me and says, well, we want to use Rocket, I can say, rock on, buddy, like, go for it. My containerizer still won't care, and I'll be able to launch your images just fine. So it gives the developers even more freedom to pick what development tools they want to use and what their opinions are, because the future of this containerizer is it will read from any image and give you a means to do a mapping. So from a hosting perspective, I don't care I care even less than I do today with Docker about how your developers do their work. And in theory, like when there are more pivots in the field of containers, this will be able to pick up that slack very fast. And I know the next bit that they're trying to implement is the CNI standard for all the networking. So you'll have overlay networks, and in theory, this cute little bug that we just found that I suspect is a bug will be solved.
And through the web UI, is there any monitoring presented for you?
Yeah, so the question was, is there any monitoring exposed to you? Mesos and Marathon both expose stats endpoints, but as far as getting stats out of the current running container, they'll either need to provide that in the agent side, which they might already have. I haven't read all of the docs. It could very likely already be there. Or again, it will have to, the agent on the host that's grabbing the metrics today out of Docker will have to adapt and grab them either directly out of the kernel, or Mesos agent will have to expose them, just like Docker daemon does today. I'd be curious to know running, I don't know how many people have run sysdig, but if you haven't checked out sysdig when actually playing with containers, it's a totally open source tool. It has an amazing ability to capture every single syscall that's going on with your containers and allows you to debug these things super deep. I'd be curious to see what sysdig can actually, I assume it's going to capture everything that it would out of Docker, so all those stats could very likely already be available via tools like sysdig. Any other questions? Sure.
Do you just have any general comments about Kubernetes versus Swarm versus Mesos? Do y'all ever think, I wonder if we should have switched over to Kubernetes?
Yeah, so the question was Mesos versus other tools. I think, so personally, I did a somewhat deep dive last Christmas to go look at Kubernetes because their story around pods was pretty convincing. It was they are genuinely trying to solve the persistence problem. And I went to go do a deep dive and get it running on CentOS. It wasn't the most easy thing to do. Followed up by, if you go look at their statements on high availability and everything else, it's definitely a second-class citizen to them that they're thinking about after the fact. So I didn't want to deal with any of that. I wanted to deal with a robust project that had been around for a while that wanted to actually be up and in a production setting. As far as Swarm goes, Swarm wasn't in the state that it was in today. Back then, it's definitely a viable candidate. As you can see, Swarm scales probably fine for everyone in this room. It's like all software, not without its bugs, but for people getting started or starting to learn how distributed systems work, I think Swarm is the perfect platform to go learn how to do that. There's a lot fewer moving pieces because they've just baked all of that into the daemon, for better or worse. Alrighty. Cool.
Awesome. Thanks a lot, Alan.